Hi, now we are going to see how a linked list actually works. In general, linked list consisting of a node. So, node is nothing but it will be having two different types of field. The first field is it will be having a data field. So, within which we will be storing the numbers. Take for example, two, and I will be storing one more other node. So, node is nothing but the combination of both data node and the next node. So, that is what we will be calling it as a node. Next node is nothing but we will be using the next node just to point the address of the previous node. So that's what we will be calling it as a next node. That's how the linked list will be looking like a chain of similar type of data types will be used. Take for example, if I'm using two here in the sense, take for example, I can't able to take a character A here, so that's impossible. So we can be able to take only three, four, some similar type of data types has to be used in a linked list. And what are all the different types of operations that we can be able to make in a linked list is one is insertion, and we can be able to do deletion as well. So, in insertion, we can be able to have three different types. One is we can be able to insert at the first, and we will be using insert at a particular position. Take for example, in an argument, we will be giving two different types. For example, I need to insert a value in the position 2. Here, I need to insert one more other node, wherein all the nodes are interconnected in the sense this is the second position. So, why? Because our array will be starting with the index 0. So, this is what we will be calling it as a second position. Over here, one more other value has to be added. So, we need to specify the position here. So, here 2 means it has to be added in the third position. And what should be the nodes value that should be here means I am taking 2. So take for example 2 in the sense 2 has to be added over here. Likewise, in a particular position, we can be able to add a new number. And also we can be able to make insertion at the last position. So wherein within a node, we will be adding a new value at the very last node. So here we will be adding a new thing. So that's what we will be calling it as a insertion at the last. Likewise, in deletion as well, we will be having three different types. Deleting the first node. So wherein take for example, I have a series of nodes. If I can be able to delete the first node, it is delete first, and we have delete last node. So wherein we will be deleting the last node. So this is what we will be calling it as a delete last, and this is what deleting the first node is known as delete first. Deleting a particular position, so which is similar to that of the inserting at the position. Here also we will be giving only the position. Take for example, the second position node has to be deleted in the sense this will be getting deleted. The last position with respect to the indexes will be getting deleted. Here, take for example, the index starts with 0, 1, 2. So such that second node will be getting deleted in delete position. So let's try to implement this code over here. Here, whenever we were about to create a linked list, in general, what we need to do, we will be specifying a class main, and we have public static void main string args, and over here we will be using a linked list. So we will be specifying that linked list of list is equal to new linked list. Yeah, we have to specify this. After specifying, so we need to create a separate class for this as well. How we can be able to do that? Class linked list, which has the values like here, take for example, firstly we have to create a node. So how we can be able to create a node here? So node generally consisting of two fields. First is a data field and a next field has to be created. So we need to create this for a class node. So how we can be able to create this means we need to specify something known as head. So head is nothing but the first in the chain of linked list here na, so in the total chain, so whenever there is a first node, so we will be calling it as a head. Anywhere it is not about to get changed. Anytime it is not going to change. So first node will be called as a head node. We need to specify that node head, and then we will be specifying what is node here. So it's showing in red now, so we need to clear that. So I'm going to write like class node, and here I'm going to specify these two fields. First this data field and the next field. Here I'm going to specify this as an integer type. So integer type of data type. So integer data, and I'm going to use node of next, which is nothing but the nodes next will be called as the data type. So why I'm mentioning it as node type means we all know that like in a node, so take for example, it is a simple node. It will be carrying this partner. So this will be carrying one more other node. So which is nothing but a data type of a node, right? This is a node and this is also a node. So here the nodes next also contains in another node. So like that's why I'm just specifying this as nodes next. So uh, this is also a data type here, but the data now, so that is of integer type. Here we will be mentioning like 1 2, likewise only we will be mentioning so such that it is of type integer. So data is of type integer and the next should be of the type node. Why? Because it will be connected with another data type of node. So that's why only we will be giving it as a node. Okay, after mentioning this, we need to specify what a node is. So for that, I'm going to create a constructor. For this class, I'm going to create a constructor. So I have created it, which has an data, so of integer type. So that's why I'm just mentioning one more other temporary variable, integer x over here, which actually specifies data as x. So such that this 1 2 all these types of values has to be specified as x, and then we will be specifying next node as null. So here only we are going to create the node. So take for example what this node line number 8 specifies is, here take for example I am creating a node of a constructor wherein I'm just initializing. It takes a value, take for example 20, in the sense this 20 has to be assigned in the data field, and the next has to be null because it is a single node. It is not interconnected with the other nodes like this. So it is not connected. That's why a single node should be defined like this. That's what we have mentioned over here. Here we will be mentioning. After this, we are going to create a function insert stat. So take for example, here public node insert stat. As we have already seen, we are going to see insert first, insert last, and in particular position, we are going to insert something as well. So I have mentioned it. The written type should be of node. Why? Because take for example, even in insert start, so even in insert start, what we will be doing is, let's just imagine a situation here. I will be having a new node. So this new node, I will be specifying it as a data type of node. This is what I'll be calling it as a new node. First thing I need to do in insert start. After that, I will be having my own previous linked list, right? So which has, we all know that the first node will be the head node, right? So in the first node, as the name states that insert start, the new node has to be inserted over in this position. So new node has to be here. What should we need to do over to insert like this? So Nothing. Like we need to initialize this head to new nodes next. So we need to write like that head is equal to new nodes next dot next. So likewise we need to write it, and then I need to mention this new node as head. So likewise only it will be converted to a normal linked list, right? So that simple. So such that what will happen? Already there are only three nodes. I have added one more node. So such that at final, after insert start has been happened, so we will be having four nodes here, and our new node, this new node has to become as a head. So that's why I have mentioned it as a head. That's it. And one more thing, as I have mentioned it as a written type of node, what should I need to do? I should return the type as written head. So head is nothing but the node that I have inserted newly, right? So insert start should return head. Head right now is right now after insertion it will be not the previous one, it will be the new one which has been generated, which is nothing but the new node that we have generated has been converted to head, and that will be getting written. Let's implement the code here for this. So here we have mentioned it as insert start, which should have a data field, right? So only the argument that we will be giving here is like here. Take for example, here I'm going to give a value like 20. Take for example, this 20 will be getting inserted over here. The data field, I need to mention it over here. So what it is, integer data. After mentioning this, I need to like newly declare the new node. How we can be able to do that? Node, new node is equal to new node of data field. So such that I have already declared this new node with its data field as 20. First step. And then in the existing linked list, I need to add the new node which I have created. For this, already the existing linked list head has to be assigned as new nodes next, new node dot next. What will happen here? The head will be assigned to new nodes next. As I have already said, this is the new node. What is new nodes next? The second box, right? Second compartment. This is of the data type as node. So we are pointing a node to the second compartment. That's how it actually works. We have also inserted this. After this, this is the second step. After inserting this, we need to initialize new node to head, which is nothing but we will be having a new node now. So that has to be converted to head. Yeah, we have done that. After this, what we need to do is we need to return the head. Why? Because head now has been converted. The new node that we have created will be converted to head, and we are going to return that as well. So this is how we can be able to make insert start. After doing this, let's create one more insert at the last position. So how we can be able to do that? Inserting at the last position means we will be giving return type as void, because we won't be carrying the same. If we need also, we can be able to insert the same. Just for some more other variant, I have given it as void. Insert last, and it also carries some sort of data. So take for example integer data. Let's see how this works. So integer data, in insert last, what we will be doing is insert last is the operation here we are going to make. So for that, we will first we will be creating a new node. As like previously we have created, we will be creating it. We will be also having a data field as well. For that, first step, after completing this, we are going to check two different conditions. There is no existing linked list. So previously we had a chain of linked list now. So over there, if it is not there like this, so it is the first and foremost node that we are going to create. In the sense, we know that simply we are going to assign, there is no head here because there is no linked list, there is no head. So that's why head has to be assigned to new node. So the coming new node should be its head. So such that only one node is present. Both are head and new node, both are same only. So this is the first criteria. And what about the second is, in the second scenario, we will be having an existing linked list. So here there is no existing linked list. So that's why a single node which is coming as a new node will be had as a head, will be converted into head. But here we will be creating there is already an existing linked list, and we are about to create one more other new linked list that has to be connected over here. So we need to connect it here. For this, what we need to do is simply I am going to create a temp. Okay, so this is the head node, right? So this has to be assigned to temp. First thing, we need to assign head to temp. We can assign like this: node which is of temp is equal to head. This is the first step that we are going to do. And then second one is until, because we are not going to insert at the first. So first operation, it's like we need to insert at the last, right? So in this position we need to insert. So for that, what we need to do, we need to iterate throughout the nodes. So that has to be done. So for that, we will be using a while loop. So what while loop will be doing is temp dot next not equal to null. So until that, this particular while loop has to be executed. So wherein, take for example, which actually states that whenever like the node will be becoming null, we have to execute the same. So such that what will be the outcome that we will be having in the linked list? So this will be becoming a temp, right? So such that in the linked list, until this loop will be getting executed. After executing, what we are going to do is, so such that we had this, right? So we had temp here and we are going to have a new node here. Okay. So this is the new node. After completing this for loop, after completing this while loop, the third step is we need to assign the new node to temps next, right? So the new node has to be assigned to temp dot next. So we need to do this. How we can, so that's it. Simply we can be able to create it. So let's try to convert all this into a code. So insert last. Firstly, what we are going to do, first step is we are going to assign head to temp. Simply write, before that we need to create a node, right? So node, new node is equal to new node of data. So previously for insert start also we have created the same. And if head is equal to null in the first scenario. So here na, in the first scenario we have made it if head is equal to null. So such that there is no elements present. There is no head itself is present, in the sense what we need to do. So here we need to make coming new node to head. The newly coming new node will be the head here because there is no head is already present. And then if not, there is an existing thing is there, means we are going to create a new node temporary. This is the second scenario. This is what we are going to convert it into code here. So firstly, we are going to create like node temp is equal to head. Head, we have created it. And after this, while of temp dot next not equal to null. So such that all the values will be executed until the temp will be becoming null. So we will be executing this such that temp dot next should be assigned to temp. Temp is equal to temp dot next, which is nothing but, take for example here it is temp, in the sense temps next is temp. So what is temps next? This is a temp dot next. That has to be converted to temp. Again, this will be the actual temp. Temps next has to be converted to temp. Likewise, each and every time the iteration will be getting executed unless and until this is the last and final node. We have converted this. After doing this, what we are going to do means we need to assign new node to temp dot next. How we can be able to do that? New node is equal to, so the node which we have created newly has to be converted to temp dot next is equal to new node. And after completing insert last, we are going to do the third thing. How we can be able to insert at a particular position. So take for example, insert last we have completed. And what about how we can be able to insert at a particular position? So for that, we will be using a function insert position. So for insert position, take for example, I have a linked list. It's a connected linked list. I have four elements in this in the sense. So insert position of 3, comma, I'm taking a value like 25 in the sense. On the third position, here we need to count from 0, 1, 2, and 3. So what will be the third position here means here. Here we need to insert the node which consisting of value 25. That's what we need to do. So such that the output should look like uh, this one, like 0, 1, 2, 25 has to be inserted here and this node has to be here. So here we need to do like this. So such that if we have given 3 means on the fourth position, it has to be getting inserted. This is what we will be calling it as an insert position. And we are going to code it for this. How we can be able to do this? For inserting at a particular position, so in this position, so we can be able to check. So firstly, we are going to check the size of the array. Here, what should be the size of the array in the sense? Take for example, the size of the linked list can be calculated via a calculate size. So we will be creating a function separately for this. So a function has to be created. And after this, so this is the first step we will be creating. Secondly, what we are going to do is we are going to check. So we are going to insert that. Take for example, we have only of size 4, but I'm saying like seventh position I need to insert. So it they as the size is itself 4 and there is no seventh element. So such that how we can be able to say n is greater than size, the given size. So size is itself is 4 and it is of 7. So in this case, and then if there is no, take for example, there is no more in -1 position or -2 position or in those types of positions or zeroed position. So there is no zero, right? So on the first position, we can be able to insert. Here, this is what is the first position. So like if n is greater than less than that of 1. So if these two conditions have been executed, we cannot be able to insert a newly coming element. So we need to convert this into code. And then we are going to take the second one, wherein, take for an example, here I have an else condition. So which says that even here we have all these types of things. So we can be able to insert at a particular position means we can take like firstly we need to first condition is we need to create a new node. So which says that new node is equal to I'm going to create a node. After creating this, after creating a new node, what I'm going to do is here I'm going to create a temporary variable. So which states that after creating a new node, within the temporary variable, is nothing but for we have a linked list, right? So within the linked list, I'm going to make my head node as a temporary node. Second thing, after creating this, I'm going to run a while loop, so which will be running like minus minus n was greater than 0. Let me explain this first. So on the third position, take for example, on the third position, here I need to get inserted a new element, this position. So I need to insert here. This is of the fourth position. Take for example, while minus minus n of 0 in the sense, here let me do the major operation here. What I'm going to do is temp dot next has to be assigned to temp first thing, and then I need to assign. So this is what we are going to do. So here, take for example, we have three. Third position we need to insert. So minus minus of 3, which is greater than 0. We need to find the value for this, and minus minus of 2 is greater than 0. And we have minus minus of 1, which is greater than 0. So what is minus minus of 3 in the sense? In post operation, so what we will be doing is this 3 na, so 3 is already there, and we are reducing a value to 1, so such that 2 will be becoming greater than that of 0. And here 1 will be becoming greater than that of 0. Here 0 will be becoming greater than that of 0, because 1 minus minus is 0, but this condition should not execute. So that's why I'm just leaving this. Only two times this while loop has to execute. Two times only it is getting executed for this use case. So for third position, I need to insert 25 in the sense only two times this while loop is getting executed. Okay, let's imagine what's happening over here. I have the nodes. I have four nodes, right? So I have all these types of nodes, and I'm going to insert 3 comma 25. This one 25 on the third position, right? So 0, 1, 2. Here the nodes has to be detached, and then it has to be connected. Here we need to connect it. So what we can be able to do for this? For connecting here, I am going to insert two times, right? So this loop has to be inserted two times. So such that initially temp is the head value, head here. So this will be connected as head. On the first time, whenever the loop is getting executed here now minus minus time, this is what is the first time loop is getting executed. This is the second time the loop will be getting executed. First time what will happen is this will be becoming the temp. Why? Because this is the head. See, they have mentioned it like temp dot next should become temp. So temps next should become temp, correct, right? So temp dot next should become temp. We have converted it for the very first time. And then for the second time, current temp is on the second position, right? So what about the in this situation, what will be the temp? So it will be coming to the third position. This position, it will be here, right? So currently, after two times the loop is getting executed, the temp has been converted, right? So such that after this while loop, so take for example, after this while loop has been completed, this will be our temp. And what about our head? This is our head, and we have a new node. So a new node which separately contains a node which with its separate value 25. So we need to insert it here. After completing this while loop, what we need to do is simply we need to make this temp dot next is equal to the new node. So such that what we can be able to write new node is equal to temp dot next. That's it. That's it simply. So after this while loop is getting completed, we will be writing like a temp dot next is equal to new node. That's it. So let's implement this as a code. Public while insert position. So with this, which is respect to a particular position. So wherein we are going to insert it, insert position of integer n, comma with respect to the node that we will be creating. integer n comma integer data, which is nothing but 25, right? So in this case 3 comma 25 we will be inserting. This 25 has to be inserted, so this one we will be mentioning here. And here what we are going to do is I'm going to calculate the size with the help of a function calculate size, that we will be creating it very soon. So calculate size of, we will be giving the header value. So whenever the head is given, with the help of iterating the head until it will become null. So here take for example, this is what is the head. We will be iterating with the help of while loop until it finds the null value. So such that we will be making a count like 0 1 2. So likewise we will be getting counted, and count starts from 1 maybe. So 1 2 3, so such that we can be able to count. So that's what we will be doing in calculate size. We will be doing it very soon. Just a summary that I have given for calculate size. After doing this, I'm going to make if n is greater than 1, first condition, which we have created here. If n is if n is less than 1, yeah, if n is less than 1, or else n is greater than size. So in this case, what we need to do is, we cannot be able to insert a new value. Can't insert. After completing this, we have an else condition wherein we have a certain linked list and we are going to insert it in a particular position. So that's why in else condition, we are going to create a new node. First thing is we need to create a new node. How we can be able to do that? New node is equal to new node, and the parameters has to be given. So data field has to be given along with this. So data, first thing. Yeah, we have completed this. After this, we need to create a temporary variable for this. So temporary is nothing but the head value, right? So node temp has to be assigned to head. So head has to be converted. Already there is a linked list. There is a head as well. We are going to assign this temp to head. The temp that will be moving actually here. So the temp will be moving from 0 position, 1 position, 2 position. So likewise the temp will be moving. That's why we have named it as temporary as well. So yeah, after naming this, we will be running the while loop. So while of minus minus n, which is greater than that of 0. So here we have seen this particular condition wherein how it will be getting executed. See, from firstly this minus minus n, so it will be actually assigned like this. So let's complete this. Temp is equal to, so t is nothing but temp. So that's why I have written it. Temp is equal to temp dot next. That's it. So simply we can be able to write like this. Yeah. And then after all the executions have been completed from the temp, and that why, because the temp has moved from 0th position, 1st position and 2nd position. And after all the while loop has been executed, this will be the temp value and this temp and the new node that we have, right? So we need to assign it in between. So how we can be able to do that? New node has to be assigned to temp dot next. New node has to be assigned to temp dot next. Simply we have created it. After this, we are going to create a display function under the calculate size as well. So these are all the two different functions we need to create. Public void display. So what this display function will be doing is, simply it will get iterating. This is our linked list, right? So it will iterate from head and it will display all the data fields like head dot data, all the with respect to the iterated particular I value, it will be displaying its data. So we will be getting this function display. Here I will be creating a node, and the node should be head. So such that, take for example, here I have different types of fields. I have these many nodes are there, and this is my head value, right? I'm going to assign this head to node, and then what I'm going to do is I'm going to create a while loop for displaying. So this is a display function. So display is nothing but it will, so take for example, I have 5, 6, 8. So all these values has to be displayed in a linked list. So 5, 6, 8. Likewise, the linked list has to be displayed in system.out.println, and in the sense what we can be able to do, while of node not equal to null. So it will run until this particular field will be becoming to null. So it will not feel any other nodes are there after 8. So until that, this while loop will be getting executed. We can also mention like node dot next not equal to null. This is also a different use case that we will be using. Node dot next not equal to null. Here what we are going to print is nodes data, node dot data, particular nodes data has to be printed. And what we need to do is we are going to assign nodes next to node, such that node dot next has to be assigned to a new node, assigned as a new node. So what is, take for example, here I have 5 and I have 6. This is nodes next, right? This is node dot next. What about node here? This is node. So what I'm going to do is this nodes next has to be assigned to node. So now this will be converted to node, and this is not the node anymore because we have converted it. That's how each and every time all the values will be allocated and it will be moving forward. Likewise, it will be moved from 5 to 6 to 8. So likewise, we will be iterating. So let's convert it into code. Here we have assigned new node is equal to head. And after this, we are going to run the while loop. So while of node not equal to null. If node is not equal to null, I'm going to print nodes data, no, node dot data, node dot data. After I have printed the node dot data, I will be mentioning it like node dot next because it's the second step, which is nothing but we will be allocating the new nodes next to the actual node. So node dot next has to be assigned to node. Node is equal to node dot next. And I'll be giving, that's it. So we will be creating a display function. And one more function we are going to create, which is nothing but public integer calculate size. So which is nothing but we will be calculating the size of the node. So we will be giving like node of node. So what calculate size will be doing is, so here we will be having calculate size. So we will be giving the node, head node we have provided it previously, right? So here, see, we have given a node as an input. So head as an input. Head is nothing but a node, right? It's a combination of data field and a next field. That's why we will be calling it as a node. That we will be passing it as an input over here. And we are going to mention it as integer size is equal to 0. As of now, initially the size will be 0. After this, we are going to iterate. So how we can be able to do this here? Take for example, firstly, I will be having the size as 0 initially, and we will be having the linked list here. All the values are here, which are actually interconnected. while we will be having this as node, right? So node of next is not equal to null. So in that case, so this node na, so this node will be moving from one over here with the help of while iteration. So while node dot next is not equal to null. So until that, this while loop will be getting executed. What we are going to do, we are going to make nodes next to node dot next, which is nothing but this is nodes not next, and that has to be converted to node. So node dot next is equal to node. We have converted this. Each and every time there is a size 0 that has to be incremented with the help of size plus plus. So which is nothing but the count of the size, count of the linked list that we will be having, 3 in this case, right? So we will be writing this. Let's try to execute this. Here we will be having node, right? What is node dot next over here? So actually 3 iterations should be there, right? Node dot next, here initially it will be the node. So that has to be moved over here, and second time it has to be moved over to the second part. This will be the node over in the last while loop, and in the second while loop the intermediate one will be the actual node. So likewise all the values will be getting interconnected with each other. So this node will be moved to the second one in first iteration, and it will be moved to the third one in the second iteration. Anyways, so we can be able to implement it as a program. So such that while of node not equal to null, in the sense we are going to make node is equal to node dot next. We are going to write the same as a code, and we are going to make the size as well as to be getting incremented size plus plus, and we are going to return the size. Size is nothing but the number of linked lists are there. So here 3 linked lists are there, na? So that will be written as size. After creating this, the size has, after returning this, let's try to implement the linked list. So in the main program, what we are going to do is, we are going to write all the functions that we have created as of now. So one is based upon here, like let's write like L dot insert start. So it will be coming like what are all the functions that we have created over here, it will be displayed over here. So insert start, here I'm going to insert 3 first. After this, I'm going to insert L dot insert start of value 2, and then I'm going to insert L dot insert start 1, and let me display all these values. So L dot display, and after this L dot insert last of 5, yeah, and after this L dot insert last of 6, and we will be having L dot insert last of 7, and L dot insert last of 8. L dot display, and we will be having L dot insert with respect to the position 3 comma 25, and I'll be displaying all the elements as well. So let's try to dry run this and try to get what will be happening. So here, take for example, we will be having insert at the start, right? So this line. So firstly, we will be inserting 3, and after that we are inserting at the start position, so such that what will be the start for 3, it will be 2, so 2 will be inserted before this, and after this we will be on this line. So what we will be doing, so we will be inserting 1 over here, so we will be displaying all these types of things in here. So here we will be displaying this. So this is what is the first thing. After displaying, so we will be having 1, 2, 3 as the linked list that we have created. And what I'm going to do is, in the last position, I'm going to add 5 again. So we will be having like 1, 2, 3, 5. Insert last with respect to 6. Okay, and then we are going to add 7 at the last, and then insert last with 8. So we will be adding that. And we will be displaying all these types of things in display. We will be having insert position at third position with a value of 25. What is third position here? 0, 1, 2, and 3, right? So this is what is the third position. In this third position, we need to fill with 25. How we can be able to do that? So what will be the output then? 1, 2, 3, 25, 5, 6, 7, 8. So this is what has to be printed over here. Let's check with output. See, firstly 1, 2, 3 will be getting printed. After that 1, 2, 3, 5, 6, 7, 8. 1, 2, 3, 25, 5, 6, 7, 8. That's it. That's how we can be able to insert all the values at the start position with respect to a particular position and with a given value. And we can be also able to add an element at the last. That's it. Thank you.